section 4.6 we're going to be doing applications. In this first problem, it tells us the population was 1,030 million and the exponential growth rate was 1.4 percentage per year. Here is our function that they gave us to work with. We're going to plug in our initial population. Our p sub 0 is going to be 1,030. Our k, which has to be greater than 0, is 1.4%, which if you make it a decimal, move it two places to the left, it's 0.014. Now when I plug that into my formula, it says write it as a function of p in terms of p. So it's p sub t is equal to, now I'm going to sub in p sub 0, which was this, then e, I'm right here, e. Now I need to raise it to the k. Well, I know what k is. That's 0.014. And then now I have a t. And I don't know what t is. So this is going to be my exponential function, exponential growth function in terms of p. B says use this function we just made and estimate the population in 2008. Well, 2008 lets us know that our t is going to be 7 because from 2001 to 2008 our time was 7 years. So now we want to evaluate p of 7. That means I'm going to put 7 everywhere t is at. 0.014 times 7. Now in my calculator I want to put this in first, that times that. I want to raise it e to whatever this value is times 1030. So p sub 7, p7 is 1,136 million. That's what the population is going to be in 2008. Okay, my next problem says, in what year will the population be 1,075 million? So if I look back, I took my original function right here and I took the right hand side of it to start with because we want to know what this value equals, okay? So I took this original function and I put it on the next page. So it says population at times t equals this. Well, they said the population is 1,075 million is equal to this. Okay, and it says what year, so I'm trying to solve for t. So essentially I want to get t by itself. But before I can do that, I'm going to divide both sides by this, and I'm just going to leave this. I'm not going to calculate it out yet. I'll save that till last. This is going to be e to the 0.014 t. Now we know problems with log we solve with, with x we solve with log, and problems with e's we solve with natural log. So to be able to unlock that, we want to be able to take the natural log of both sides. So once again, I'm just going to leave that represented as the natural log of, I'll save my values for last to put in the calculator. I want to save all my estimating to as long as possible. Now natural logs have the same properties as logs, so I can move this exponent out front, so I get 0.014 t. Then I have the natural log of e, but we recall that the natural log of e equals 1. So since this value equals 1, I have 0.014 t times 1. I'm just going to not write the times 1 yet. Okay, so to get t by itself, I'm going to divide both sides by 0.014. So I get this big whole blue thing divided by 0.014. Now I just want to be careful when I put this in the calculator. I want to do this divided by this, put it in the calculator, and you should get approximately, my time comes out to about 3.05. Well, that means if it takes it about 3 years, if we round this, for the population to get up that much, it says what year will it be? Well, if we started in year 2001, and it takes it approximately 3 years from here, then it's going to be in about the year 2004 is when the population will reach 1,075 million.